Hello, on October 29th. Lots of work. Lots of work. And very chaotic, actually, the work. Yeah, I was going everywhere. Hey, what happened here? I should have stopped it. No, I just kind of got stuck. Okay, let's do it. Minimal number of increments on subarrays to form a target array. You're given an integer array target. You have an integer array initial. You're given an integer array target. You have an integer array initial of the same size as target with all the elements initially 0. In one operation, you can choose any subarray from initial and increment each value by 1. Return the minimal number of operations to form a target array from initial. So initial is this, we do this, and we do this. Choose any subarray from initial. But basically just you have initial and then you just choose subarray to increment by 1, and then you choose another one, increment by 1. You do this continuously, eventually you reach the worst case you just do 1, but you don't need to do 1, right? So basically you're given this, right? You know the smallest is 1, so if you increment by the smallest amount, you take them away. So the first increment, right? So you can actually think about decrement, right? Instead of increment, you just do decrement, right? And you do another round of decrement, and you do the last round of decrement, right? So okay, so think about decrement. So if we think about decrement for this one, 3, 1, 1, 2. So we need decrement 1, so become 2, 0, 0, 1, right? Decrement another 1, 0, 0, 0, and then 0, 0. So that's 3 as well. But the answer is not. The answer is 4. Oh, you cannot decrement here because it's already 0, so you cannot decrement. So you have to find only consecutive can decrement. So basically this will be like this, and this will be like this, and then you have this 1, 2, 3, 4. Okay, so this one 3, 1, 5, 4, 2. Decrement once, right? And then basically you separate into 2, so you can do this part. This part needs 2 times. This part, you decrement once will be 3, 2, 0. And then this one, yeah, you keep going, will require 3 times. So 3 plus 1, 4, so 6, 7, yeah. Okay, so that's actually a good test case for this one. Definitely can find a minimum value, those are the minimum decrement you need to do. And after that, you divide it into this part and then this part, right? And then for each one, you can continue decrement. So it's just kind of, I don't know how long it's going to take, but well, we'll see. So it's kind of, it's like divide and conquer, but I'm not quite sure if that's the right term for this. And I'm also not sure what the implication is going to be on the time complexity, because you have to scan through everything, right? So that each round of scan, you will break it down into smaller chunks. And then you have to do another round of scan for those every single smaller chunks. I don't know, amortized, like how much it's going to be. And it's guaranteed each one will reduce at least one of them to 0, right? Each round will reduce one of them to 0. And like, I think the worst case scenario is, yeah, think about the worst case scenario. Actually, this is the worst case scenario, right? If you have 1, 2, 3, all the way to, I don't know, 10 to the 5th. This is the worst case scenario. First round, you get rid of this. And then second round, you get rid of this. You have to do like its own squared, right? So that's not gonna work. We need something better. I don't know. I'm thinking about sorting, but what can sorting do? Well, what sorting gives you is, you know the smallest numbers, right? So you take the first smallest number, and then, yeah, you know what it is, and then you have the second smallest number. But how do you know that they're connected? What does it mean by them being connected? Well, initially everybody's being connected, right? And then when you remove, if there are zeros, then they become disconnected. Man, think about this, like, at this position, I mean, we can say the minimum it's going to take to get this one to 0 is going to be 3 steps, right? It's just we don't know if those 3 steps can be shared, like how they can be shared with others, right? That's the thing we don't know. And to know if you can get shared, you look around you, right? You look around you. So 3, I look around me, this is a 1. That means only 1 can be shared, the other 2 cannot. So, right, so we'll say, okay, 2 cannot be shared, 1 can be shared. So for here is 1. Okay, so this 1 can be shared. So if this is, let's say, this is I cannot share, this is share. This doesn't have 1. Look at 5. So for 5, I can share 1 on this side, right? And then on this side, I can share 4. So for this position, I can share 4, and I have to do 1. For this, I can share all 4. Actually, no, I can only share 2. I have 2 others I cannot share. For this, I can share 2. I don't know, what does this do? This just means that this can share, right? But actually this section, it's only 1, because it can only but depending on which side you're talking about, right? Which side you're talking about. So if I look to my left, I say I can share 1, right? And then I look to my right, but that's different, which means those do not happen in the same round, right? So basically for this position, I look to the left, I can share 1. So the smallest, right, is I can share 1. And after I share 1, I see that this is 3, so I can share 3. So at least 1 plus 3 is necessary, right, to remove, right, to remove. And then plus 1. So this is kind of the minimum this is going to take. So like to take this down, I need this many steps. Take down the largest one. But this is only 5. I have 2 more steps, right? So basically I do this step, and then this is 3, right? I do this step, and then I have 1 more left. So basically when these are done, I need to see what else has. Yeah, so when this is done, when the largest is done, I look around. So this will be done. So I look to here, this becomes 0, so like 1. So like we have 0, this is 4, this is 3, and this is 1, and this is 2, right? And then this becomes 0, so I know this side is completely separated. And then now I do I don't know, man. Yeah, I think going down and going up is the same thing. I need some hints. Only 1 hint. Segment tree. For a given range of values in target, an optimal strategy is to increment the entire range by the minimum value. The minimum in a range could be obtained with a range minimum query or segment. So minimum. So it is, I look at the overall range, find the minimum, right? And then I do that. and then we record how much we have done, and then but we also need to know where, right? Because that's where we are going to split them up. Yeah, I think the ideal is we do the full range, we find a minimum and where they are. Right, we find a minimum value. And then this one will break it down into smaller chunks. And for each chunk, we'll find its smaller value. So yeah, so basically this chunk, now we have this chunk. Now this chunk's smaller value is 2. Right? It's actually not 2. The smaller value is 2, but we have 1 already. So this is actually only 1. So we're going to remove 1, which means for this chunk, the total will be removed 2. Now we have this chunk. And this chunk smaller is 4, because remove 2 is actually going to remove 2. Right, so in total, this one will remove 4, and the last one is this. So they'll remove 1, then we remove 5. Right, and this initials remove 1, and then we have 3 minus 1, so that actually is 2, so we're going to remove 2. So minus 2 minus 5 is minus 7. But we need to do yeah, this needs segment tree for sure. But how do we use segment tree to tell which one, the position, right? This is the problem. I don't know the position. I can pre-do the position, right? I can say, okay, 1 is at these position, 2 is at these position, 3 is at these position. Doesn't matter, right? So we'll do a range query, and we get the minimum values, right? We do this, and then we get the minimum values, and then range query for the minimum. Total length is 10 to the 5th. Yeah. Right, we have query left, query right, so we find the minimum in this range. How do we do insert? I don't remember. Update. We have update and we have query. We have 2. Update is we'll update at this position, right? Right, how do we update? How do we do segment tree? I forgot. Update. So query is we have this range, right? I want to query the minimum in this. So I query the left, right? And I query the right, and then the minimum on the left, minimum on the right, and then we pick the minimum. Okay, so that's query. It's fine. I get it. Update. Wait, always remember there's like query left, query right, and yeah, I have query left, query right. Oh, I forgot segment tree. Isn't this the value? Isn't you put a value in? Oh, I don't remember. I don't remember if it's like I put a value in or I put the index in. Okay, what I have in mind is sum, right? Like a range. What I want now is give me a range. I have the minimum, right? Give me this range. So basically, I'll query this range. Yeah, I query the total range, and then I split it in half. So I have the mid, so I'll query this half, and I'll query the other half. And then for this half, right, and then for this half, I'll get a value. For the other half, I'll get a value. Because how does it work? My God. I don't remember how it works. And I know this, it's not that difficult to write, but I'm got stuck right now. Yeah, because what I remember, you update a value, but you have to check if it's on the left hand side or on the right hand side, right? But this is different from like I forgot how segment tree works. How does segment tree work? I don't remember. I just need a general. Yeah, this is how I remember as well, right? You have the total, you have 0, 0 to 2, 3 to 4, and if you want to query this range, oh yes, now you find the middle, right? You query the range, now you find the middle, you get the left, you get the right. Okay, yes, now I get it. Yeah, you query a range, and you check if it's on the left hand side or if it's on the right hand side. Oh yeah. Range left, range right, query left, query right. Okay. Now it starts to kicking back. Yeah, like if you query the entire, then it's gonna be right in the middle, right? It's gonna be right in the middle. All right. But we can save the value, right? How do we save the value? In indices, right? And also node, that is just 0. Yes. Okay. How do we update? You update a position. Oh, whether it's on the left hand side or whether it's on the right hand side. Okay. Now it starts clicking. Okay. So, all right, yeah, I think I can do segment tree. Now, after the segment tree will give me the range minimum, right? Okay. And then once I find the range minimum, now I'll find out where they are. So each range minimum will give me the amount to reduce so far, okay? And then it's split into whatever chunks, and each chunk, and log n then. All right, so we need to build a segment tree. Need to build a segment tree to find range min. We start with the entire range, then break up target into sub-ranges from which we continue. Yeah, we continue to continue to find the minimum and break into even smaller sub-ranges. So when we have the total, right, and we have sub-range, we have the overall come into it, and then this one will, so eventually it's gonna, then we will add up all the sub-range results. Should take O and log n to complete. All right, so segment tree, the tree needs to be shared. I think I don't want to do a class, so maybe I just do private int update. Okay, so this update would take a vector tree, seg tree, and index, index val. Actually, I don't need val, I can just do the target. Target index, and then range left, range right. This is a update target index in the segment tree. Right, so I have that. I think this is not going to return anything. Void. Right. So index, if index, So range left is larger than range right, or break. If range left is equal to index and range right is equal to index, then we also have the current range left, range right, and int tree index ti. Okay, so we say sec tree ti is equal to target index. Okay, and then break. Let's break return, right? Otherwise, then I presume left and right are on both sides, and then we say mid is equal to range left plus range right minus range left divided by 2. Okay. If index is smaller or equal to if index is smaller or equal to mid, then we do update sec tree target index range left mid. That I think is 2 times ti plus 1, right? Else and then int left I is 2 times ti. Oh, root. I think it should be root. Let's just call it root, right? Root. This is going to be root, and this is going to be left child. Root plus 1, right child 2 times root plus 2. And here it's going to be 2 left. Else update sec tree target index mid plus 1, and a right subtree and a right. Right? And then after all that, I'll say sec tree root shall equal to the minimum of sec tree left and sec tree right. Okay, that's update. Right, and then we need to have a query. Again, we have sec tree, and we have query left, query right, range left, range right, root. Okay, so if impossible case this, or actually I don't know what else. So this I'll just return int max, right? This is an impossible case. I remember there are other impossible cases. So query left, query right will always be within range left, range right. I don't think it can ever be another way around. Okay, so So query left, query right. Again, mid is range left plus range right divided by 2. We'll do this as well. Okay. Now we can check if query right is smaller or equal to mid, which means everybody's on the left hand side. Then I think we can safely say return query sec3 query left, query right, range left and mid, and then left. If query left is larger than mid, right? If query left, what if query left is equal to mid? Yeah, it's fine. It's this. So I say return query sec3. Actually, this is not right. No, this is right. So query left, query right, mid plus 1, range right, and a right. Okay. Otherwise, then we'll split in the middle. Then we shall return a minimum of query sec3 query left mid range left mid left, and then we have query sec3 mid plus 1 query left query right range left range right and a right. And then I think I have missed one more. It's if range left is equal to query left and range right equal to query right, I return sec3 root. Okay, so this is the segment tree. N is equal to target size. So sec3 n shall equal to, if I remember right, we're gonna do math probably C math. Alright, I don't know. How do I do this? C++, math log 2. How do I do that? Include C math and just log 2. Okay. So log 2 n. Okay. And then we can do cost. Wait, how do I do cost? Ugh. Cost to int, I forgot. Static cost, that's the one. Static cost. So I'll cost this to int, then I'll plus 1, then I'll take power. How do I do power? Math 2 to the power. Just pow, exponent, pow and exponent, pow 2 to this expected qualified ID. What does that mean? I don't know. Did I use static cast wrong? Static cast double something. Nice, that's right. Actually, I probably don't need static cast here. So 2 to the this plus 1 power. Now we take this. I don't know. Maybe it's right, maybe it's not. Yeah, that's all right. So now we can say vector int sec3 and yeah, we set everybody to 0. That's fine. Ooh, we actually don't want to set everybody to 0 because I need to update. Update is taking min, so everybody gonna be max. And then we will say for int I equal to 0, I smaller than n, I plus plus. I'll call update sec3 target I index, that's that. Left, range left is 0, range right is -1. Root is gonna be 0, so that's update. Okay. So now what we need to do is, more than update, I also need the positions. Right? So positions, I need an ordered map. Int, this is gonna be a vector of int positions. Okay. And then we say positions target I dot pushback I. Okay, so now we got all the positions. So we got all the positions. We got the segment tree. Now what do we do? Now we need to go through the whole thing, find out their positions, break them down, call them. So I need another function called int min ops. So what do we need for this? Well, I need sec3 for sure. I need target for sure. I need I and j. Maybe I can call low and high. I think it's easier to manage. So I need low and high. So basically give me low and high and carry. Right? What are you going to return? I'm going to return the total number of operations, right? We need. Okay. Okay, so I have this low and high. So I want to know within low and high what is. So the first thing we say min val. Oh, we also need one more thing. We need a darn, unordered map. This is a vector. Right, this is a position. Right, main val shall equal to query seg3 target query left. Jesus. So query left is low, query right is high. Okay. Query left, query right. Range left and a range right. Okay. So range left, range right, root. Okay, this is, we got a min value. What else? We got a min value, then we know the positions, right? We know the positions, and positions will help us because we are going from low to high, so those positions better be within low to high, right? Okay, so yeah, we only get the positions within low to high, so we go through them, we get the positions. What's the end? Well, the end is if low is equal to high, right? Okay, let me write the end. If low is equal to high, this is the end. If low is equal to high, we point into the same thing, and then that is going to be the number of removal. What's the number? So we have carry, so whatever is being carried down, and what I'm gonna do is those carry will remove for this, and then remove. So that's actually just gonna return target low. That's it, right? This is if we are in this situation. Otherwise, we get a minimum value, and then we should say for int I of position minimum value. Okay. If I is large equal to low, well, actually, we write it better. Low is small equal to I, and I is small equal to high. This is where we're gonna split, right? So we're gonna split into low to I and I plus 1 to high. I think this is what we're gonna do, because you're gonna split, right? No. I actually doesn't. Like if, because I is the smallest, right? And then I is gone, but I becomes 0. So it should be the left side and the right hand side. We also need if low is larger than high, shall return int max. It's not possible. So yeah, because it's equal, it doesn't really make any sense. It has to be this, right? Low is smaller, I is larger. So when this happens, then we'll do, for this we get the smallest, we get this, we get this, we get this. We should add them together, right? We should add them together. So what do you mean by add them together? Because we have a carry, right? Which means from outside carry in, we do this amount of removal, right? Yeah, we do this amount of removal, and when this amount of so on the outside, I say I do this amount of removal. So for you, you will remove a certain amount for you. So it will be your amount. Isn't your amount is just going to be you by yourself? Yeah, I wonder why we need carry then. I don't think we need carry, because at each one you're gonna remove. Like if you go back looking at this, right? So at the minimum, this is a 5, and this is a 4, and this is a 2, right? So at the first I remove 1, and everybody here we say we have a carry 1, right? Then next we say this, because this actually is remove 2. From this perspective, the overall carry is 2. And for this perspective, overall carry is 4, and for this perspective, overall carry is 5. And then, because this is done, so it's actually just this part. And then this is done, actually just this part, so this overall return is 5. And then we add them together. Yeah, I don't think we need this carry. I think carry is not necessary. I don't think there is a carry. So essentially, what the hell? Query, secretary. Oh, I don't have target. All right, so this is the main value, and this is this. And then, you know, we are going to say, like in this case, right, it's equal. So it can be equal to one side, and we just, like, hold on, hold on. If it's equal, then we only, you know what, I think this is not right. I think what we really want to know is minimum. We also need what? Res equal to 0, right? Like how much gets removed from the current perspective. So for this I need to see for the left. So if I minus 1, right, is larger or equal to low, then res shall plus equal to min operations secretary. I don't even know if we need target. I think we just need an. Right? Oh, I do need target. Low equal to high. Yeah, I think I do need target. I do need target. So this target position, I minus 1 is the largest, so it's going to be low. High is going to be I minus 1. Okay. If I plus 1 is smaller or equal to high, then res will plus equal to minimum operations secretary target position I plus 1 high, and then at the end we'll return res. So that's min operations. All right. I don't think we'll call this, because it's guaranteed this is not going to happen. Okay. So now we just do return min operations secretary target position low is 0, high is a minus 1. All right, yeah, there's some debugging we have to do for sure, but let's just run this and see how it goes. Who knows? Maybe it's right. We have an issue of this is not big enough. Maybe not big enough. I don't know, honestly. Maybe I need a +1. I don't know. Nope, I don't know why. So I remember you take log, right? You take log, you +1, you do 2 to its power, and that shall be it. I think it shall be its ceiling. Maybe I have a ceiling of this. I don't know, just guessing. Nope. I think we have a few more minutes that I want to spend on this. So let's why not? I don't see why not. I think it's a good question. So target. So just target. I remember this minimum operations target. All right, I need to put. This seems to be a good position. 2030. Okay. Let's see. That'll be fun. Alright, secretary is 16. Which I think I should be fine. Okay. Update. I think this F3 is go in, right? Or F1 is going. Yeah, F1 is going. So we're gonna update. Update what? Update I the position. Index is 0. Okay. Range your left, range your right. No, no. Mid is 2. Position is 2. And then left is 1, right is 2. So index is 0, is smaller, so yes. Right? We'll do update. Now index 0, left, right. Root is 1. Smaller, yes. Equal, no. So mid is 1. Left should be 3. Right should be 4. Index is 0. Smaller equal to mid. Yes. So I do it again. Now it's still no, but mid is gonna be 0. Left and right, it's fine. And then we'll do update. Still on this. Okay. Now it's due. Root is 7, so we do 7 and then we return. And then I have yeah, the root for 3 done. Root for 1 done. done, right? Update is done. So if I see this, okay, so now position, good, next, good, next, good, I is equal to what? 3, 4, that's it. We don't even need, we actually got too much. I think 8 is enough. All right, now we're gonna do minimal operations, right? So minimal operations, 0 to 4, okay? No, target n is 5. Minimum value, 0 to 4, should be 1. Yes. Result is 0. So positions, actually I don't need, I need positions. So 0 positions. Anyway, 1, hold on, positions is a map. First is 3, size is 2. Yeah, second is gonna be 0, 4. Yeah, 0, 4. So I is 0. 0 minus 1? No. 0 plus 1 is smaller than high, so it's 1. Right? So basically, oh, that is wrong. Yeah. Okay, yeah, this is wrong. I know I can't do it this way. You have to holistic. You have to put it out and find the things in between. So basically here is not right. So what we need, oh Lord, is the first one. Okay, and we check. So we have low and the first one. So we check if there's anything in between of them. Once we do, and then will be the second one. The second one we're checking in the front. So basically this is going to be int I equal to 0, I smaller than position min val, right, dot size I plus plus. If I is equal to 0, right, then we'll always look into the left, right? If I is equal to 0, I see. If low is larger than high, I will return 0. If I is equal to 0, and then the left should be, yeah, it's just low, right? So res plus equal to min ops, you know, sec tree target ops low and I minus 1, right? Else res plus equal to min ops sec tree target ops, the ops positions. So I will be this. Yeah. And then this I will be whatever to the First of all, this is not I minus 1. This shall be position min val I minus 1. No, I minus 1. Okay. This shall be position min val I minus 1 plus 1 and position min val I minus 1 all the way to the last one. Else if I is more, so I is the last one. Actually no, this is good, right? And then I'll handle the last one plus equal to min ops sec3 target position. So last one is going to be, so yeah, add the last one, minus 1 plus 1, and then this, right, as the last one, so it shall be position min val dot back plus 1 and high. Okay. Not sure. Let's take a look. Oh, first one's right, second one is wrong, third one is wrong. I think it's just a little bit tweaking. But I am not going to tweak now. I am just going to copy and paste. Also, I do think this is probably not necessary plus 1. Yeah, let's just keep it. This is interesting. This is the solution? No. I am still going to implement the other one. But it's interesting, I need to read through this. It's like that simple. Huh? What do people say? Oh Lord. Oh Lord. How do I close this? Oh. What do people say? People saying it's very easy. Well, I guess if you figure out the method, but for me it's not, because I am trying to segment tree this baby. We will segment tree it. All right.